Let's go over a couple of examples for this week's discussion quiz. Question 1 is multiple choice, meaning you are only graded on the answer. You'll put a capital letter in this box that corresponds to your answer. We're asked to evaluate this right-hand limit of this rational function, that is, as we approach -2 from the right. A good starting point is to check just by direct substitution. What happens if you put -2 in place of all the x's? Again, this plus sign means you're approaching -2 from the right side. So if I substitute -2 into this expression to see if we get a value, this is -2 cubed divided by -2 plus 2. And this is equal to -8 over 0. Unfortunately, direct substitution did not work. We divided by 0, and this thing is undefined. However, in a rational function, if you ever have non-zero over 0, that means there is a vertical asymptote at this x value, -2. That means the answers cannot be a or b, as those are real numbers. The answer must be either positive or negative infinity. So here's the approach that I like to take. I'm going to pick a number that is close to -2 on the right side of it and plug it into this expression. I'll see if that value is either large and positive or large and negative, and that way I can decide between either C or D as the correct answer. So on a number line, if you look at the number -2 and you are approaching it from the right side, so that's what that plus means. Again, that means we're approaching from the right. I'm going to choose something on this side that's close to -2. There's a lot of choices, but I think I'll go with -1.9. I'm going to take -1.9, I'm going to put it into this expression, and then reason out if it's large and negative or large and positive. So here's what that looks like. This is -1.9 cubed divided by -1.9 plus 2. Now this is a real number, and all I care about is it big and positive or big and negative? So the top is a negative number cubed, so I'm just going to note that in this fraction, the top is negative. I don't even care what the number is, but I do know that it is a negative number. Same thing for the bottom. -1.9 plus 2 is 0.1, so that's positive. But not only is it positive, it's positive and small. And I'm noting this because if you divide by a small number, the net result is going to be big. Furthermore, a negative divided by a positive ultimately is negative. So I can state that, okay, whatever the answer is, I know it's negative, and I also know that it is large. Again, that's because we divided by a small number. So of the two remaining choices, which makes the most sense? Well, large has to be some type of infinity. I know it has to be negative, and therefore the correct answer is C. And so I'll put capital C in this box. Question 2 is a free response question, meaning we're graded on the answer and also the work that we provide. Here we have to solve the limit as x approaches 3 of this rational function. A good starting point would be maybe we can use direct substitution. Just simply put 3 in place of all the x's and simplify that number. Unfortunately, I think direct substitution will not work. In the numerator, we get 9 minus 9. In the denominator, we get 9 plus 12 minus 21, and this is a 0 over 0. So unfortunately, direct substitution did not work. But we'll take a different approach. Maybe we can simplify this rational expression to something where we can put 3 into the resulting equation. So let's try that out. So this limit up here is equal to the limit as x approaches 3 of, okay, well, can we factor the top? That's a difference of squares, so I think we can break it apart into 2 linear pieces. And I believe the same thing will be true for the denominator. So in the numerator, we have an x times an x. I know it ends in a negative number, so we have to have a positive and a negative. So we need 2 numbers that will multiply to -9 and cancel the middle term, which is not present here. It has to be 3 and 3. 3 times -3 is -9. If you add these together, you get 0, which is why there's no x term here, and this factored the numerator. If you look at the denominator, I think we can also factor this into 2 linear pieces. It has to be an x and an x. That's how you'd multiply to an x squared. Again, you have a negative, so I know we have to have a positive and a negative. I need 2 numbers that multiply to -21, yet add to 4. And I believe 7 and 3 work. 7 times negative 3 is negative 21, and the sum is positive 4. So this limit is equal to this limit. Furthermore, you can cancel the common factor of x minus 3 and consider this limit instead. This is the limit as x approaches 3 of just what remains, x plus 3 divided by x plus 7. You don't need to include the parentheses anymore, as we only have single terms in the top and the bottom. This limit must be equal to this one, and that's because I don't care what happens exactly at 3 in this expression. Now, can we put 3 in place of these x's to simplify it down to a single number? And the answer is yes. By putting 3 in place of this x, we will not be dividing by 0. So by evaluating this limit, this is 3 plus 3 divided by 3 plus 7, which is a 6 divided by 10. And if you cancel the common factor of 2, that is 3/5. So the final answer for this limit is that it does exist, and it's equal to 3/5 when simplified.